Hello everyone. So in this video we are going to discuss the 10th problem of BMATH 2008. So let's read the problem. So the problem says that if p is a prime number and a is greater than 1 is a natural number, then show that the greatest common divisor of the two numbers a minus 1 and a to the power p minus 1 divided by a minus 1 is either 1 or p. So to find out the GCD, we have many techniques, but the two most common techniques are the division algorithm or the factorization. So here we don't know what is exactly a minus 1, but we can't factorize. So let's go by the division approach. So first of all, we know that this a to the power p minus 1 divided by a minus 1. So a minus 1 will divide a to the power p minus 1, and that will be a to the power p minus 1 plus a to the power p minus 2 plus dot 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 a plus a to the power 0, which is 1. Okay. So as you can see here that this is the number, and I have to find the GCD of this number with a minus 1. So now how do I divide this number by a minus 1? So that is one concern. So if you know congruence, so you can apply that. So what we'll do, so a to the power p minus 2 plus dot 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 a plus 1. So I can write that this is congruent to, so let's see, modulo a minus 1. Okay. So now you are saying that how I don't know a minus 1, how will I divide, or how will I take the modulo under a minus 1? So if you don't know that, so let's see the maths behind it. So a minus 1, this number is congruent to 0 modulo a minus 1. Now a is greater than 1, so we are safe here. Now so this number divides itself, as simple as that. So from there we can say that a is congruent to 1 modulo a minus 1, and so we can use this in our this relation here. So we can say that this thing, so that means a to the power p minus 1 would be, like if I take both the sides to the power p minus 1, then you can very well understand that a to the power p minus 1 is also congruent to 1 modulo a minus 1. So this will be nothing but 1 plus dot 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 1 p many times. Okay, because here you have p such terms, and the last one is 1, of course. So this is basically this number a to the power p minus 1 plus dot 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 till 1 is getting congruent to p modulo a minus 1. Okay. So now let's come to the GCD part. So we have to find the GCD of a minus 1 and a to the power p minus 1 plus dot 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 till 1. Okay. Now I can also write this as, so a minus 1, and this number I know that it's a minus 1 times some integer k plus p from this relation here. Okay. And so now if suppose the GCD is d, okay, suppose the GCD is d, then d divides a minus 1, and so d should divide this whole thing, that is a minus 1 times k plus p. But since d divides this part, it also implies that since d has to divide the whole thing, so d should also divide p. So if d is the GCD, it should divide p, and it's given that p is a prime. So it implies that d is either 1, d is the GCD of these two numbers, so it can be either 1 or the prime number p which is given, and thus we are done. Okay, so thank you for watching. See you next time.